The last thing that we're going to talk about today is Descartes' rule of signs. And basically this gives us some information about what types of solutions we're going to have before we start solving. So it will help us to determine the most positive zeros that a function can have, the most negative zeros that it can have, and what combinations of positive, negative, and imaginary solutions we can have. So to determine the most positive roots, we're going to start with our p of x and look at the polynomial and see how many times the sign changes. So how many times do we go from a plus to a minus or a minus to a plus? And so however many times that the sign changes, it's going to be the number of positive roots. That's the biggest number of positive roots. But then it can be less than that number by an even number. So it could be less than that by 2, by 4, by 6. Now, of course, you can't go into negative numbers here because it doesn't make sense to count the number of roots in negative numbers. So you would stop when you got to a 1 or a 0. The number of negative roots for that same function p of x is going to be the same as the number of sign changes for p of negative x. So we're going to have to go in and replace every x with a negative x in order to count sign changes. And then the same thing applies, that it can be less than that by an even number. So again, using p of negative x, so we're going to evaluate our function at a value of negative x to do that. Let's see what that looks like. It'll help to see the example. So we've got this polynomial. It's a 6th degree polynomial. And so right away, before doing anything else, I know that the total number of roots that I'm going to have is 6. I don't know what combinations of positive, negative, and imaginary, but I know that when I add those together, it's got to equal 6 because I have a 6th degree function. So let's take a look at f of x and see how many sign changes we have. Now the first thing I want to do is I'm going to put a big old positive sign there on the x to the 6th so that tells me, oh wait, that's a positive number. I know we don't normally write that, but in this case I want to physically see the sign. I go from a positive x to the 6th to a negative 2x to the 5th, so there's my first sign change. And then the next sign that I see is a positive, so there's another sign change. And then from positive to negative, and then everything else stays negative, so no more sign changes. So if I count those little arrows, I have 3 sign changes. So that means that the possible positive zeros, I can have as many as 3. But I might also have 1 because it says less than this number, less than 3, by an even number. Well, the first even number that I would run into is a 2, so 3 minus 2 is 1. So we have 2 different choices for our possible positive zeros. Let's make ourselves a note. 2 choices for our positive. Now we want to talk about how many possible negative zeros there are, but remember, first we have to evaluate the function at negative x. So I'm going to write f of negative x, or remember we could also read that as f evaluated at negative x, and that's going to be equal to negative x in parentheses. I'm going to put a negative x in parentheses everywhere that I saw just a plain old x before, and that's to the 6th, minus 2 negative x to the 5th plus 3 negative x to the 4th minus 10 negative x to the 3rd minus 6 negative x squared minus 8 times negative x and minus 8. We need to simplify this and get rid of all of those messy parentheses now. So I need to be thinking, if I have an even number of negative x's, that means that I can pair up in pairs of 2. So if I take a negative x times a negative x, that's 1 pair, and that makes a positive, and I can do that 3 times. So that means that overall, this is going to be a positive x to the 6th. If we look at this next term, I have a odd power. And so I can pair up two sets of two negative x's that will end up being positive, but I have a fifth left over. So I know that overall, whenever I remove the parentheses here, it's going to be a negative x to the fifth, and I need to multiply that by negative 2. The two negatives will make a positive 2x to the fifth. And then we're going to continue the same way. If I see an even, I know that the overall x to that power is going to be positive, and if I see odd, it will be negative. So I'm going to have a plus 3x to the fourth, a plus 10x to the third, and then a minus 6x squared plus 8x and minus 8. And let's look at the number of sign changes. I don't see a sign change until here, positive to negative, back to positive, back to negative, so that's 3 sign changes total for our negative zeros. So I can have 3 or 1 just like my positive ones. And let's make ourselves a note that we have 2 choices here. So if I have 2 possible choices for my positive and 2 possible choices for my negative, if I take all of the combinations of those, 2 times 2 is equal to 4. I need to take into account 4 rows, and that's what I have in my table. My positive solutions, I'm going to take a 3, and I'll pair it up with the 3 and the 1 from the negative. So I'm going to need to write the 3 twice and the 1 twice so that I can pair it up with the 3 and the 1 from the negative. So I can do a 3 here, a 1 here, 3, and 1. And notice that I have all 4 combinations taken care of now. And the final thing I want to do is figure out the number of imaginary solutions, knowing that my total has to equal 6. 3 and 3 is already 6, so 0 imaginary. 3 and 1 is 4, 2 imaginary, another 2, and a 4. And that will fill out our rule of signs table.